with Gain to talk about how we at Epigos AI are building computer vision tools to help businesses and researchers. And in this particular session, we'll focus more on agriculture. So I will do a short presentation, about 10 to 15-minute presentation, and then we'll then go into the platform, and then I will showcase how you can use the platform to, to build a computation vision model and deploy. So without taking my time, I will start the presentation. And if you have any question, you can note it down. So after the presentation, you can then ask the question. And after that, we'll move on to the demo as well. And you can also ask more questions after that. Yeah, so this a quick intro about myself. So I'm a software engineer and AI expert. And my background is in, I started as a biological science and then moved into doing my master's in data science at City University of London. And where I currently also serve as an honorary visiting fellow at City University of London. And mostly I've worked mostly in the, in the AI sector, as a software and AI engineer. So a quick intro of our presentation today. So we'll just do a brief intro of Epigos AI, and then why the need for computer vision platform in the Agric sector, and then the whole computer vision training and deployment pipeline. Then also look at how we can acquire data sets and annotate it and prepare it to train a computer vision model. Then we'll also go through the training and evaluation process, and then finally the deployments and a live demo on the platform. So brief intro of Epigos AI. So Epigos AI is a no-code platform to annotate data. So we provide you with a hands-on tool for every individual, whether you have a technical AI background or not. With our platform, is no code, so you don't need to write any code actually to use our platform, and you can train and build your own computer vision model. So be it you are, let's say, a researcher or an agronomist or a business person that wants to kind of build and train models to do a specific task. The platform currently is designed for computer vision models, and so which has various applications in a lot of sectors. And the platform, with the platform, you can have all your data that you want to use to train your models uploaded to the platform. And then one key, concept of preparing data sets for computer vision is image annotation, which I'll go much deeper in the few slides. And so we have all the annotation tools on the platform as well to make the labeling easy. So you can collaborate with your team to label all your entire data set. And then we also provide auto labeling feature on the platform, which also assists with labeling, so that you don't have to do all the labeling manually. And then on top of that, the platform have all the GPU. These are computing resources that you will use to train your AI models. So you don't have to pay for any, expensive or, have your own GPU running locally to be able to train the models. And then after the model is trained, you then have it deployed and you can start using it right from there. So why we're talking about computer vision in agriculture? So with computer vision, it turns every computer, every camera into an expert, right? In this particular instance, an agronomist in the agric sector. So with just a vision model and a camera, you can do early detection of diseases, count your crops, do check if there is any pest or anything that is, affecting your farm or going to potentially impact your yield. And currently the the problem is that about 40% of crops are, are damaged, and it's affecting yield in sub-Saharan Africa. And with more automated, tools, this can easily improve the yield. Imagine having to, screen your entire field, like hectares of, land, to be able to detect if there is any disease in your farm or not. But with automated solutions, you can deploy your AI model in a camera and embed it in, let's say, a drone or some similar embedded device that can fly over your farm, capture the images, and do the analysis for you. So this is very key, and the impact of computer vision in Agric is is growing and is being applied in a lot of countries currently. So here are some case studies of projects we've done so far at Epigos AI. So one, we worked on with an agronomist to build a cocoa disease detection model. So here the project started by the agronomists going to the field with farmers to capture images of cocoa, and then he uploaded to the platform, labeled it, and then then we labeled various aspects. So here you can see a healthy unripe pod, healthy ripe pod, and then a black pod. So this is currently an internal project, so it's not meant for demonstration purposes. So this project is also quite successful, and is currently, we are looking at how we can integrate it into different farms. And then there is also another case study here. Is insect larvae identification. So this is also a peculiar situation. This shows you how versatile and computer vision is, can have various use cases. So this particular business is based in, so they use organic matter they have kind of this insect that feed on organic matter and convert it into fertilizer. So they are based in the west of Ghana and Legon farms. So they have this particular problem where they have to manually count the larvae. So the larvae feed on the organic matter. So they put in each cages about 5,000 insect larvae that's supposed to feed. So this number has to be accurate for them, because if they put more, it affects the outputs. And then if it's less too, it kind of have an impact. So what they were doing was they were manually counting this larvae, and these insects are moving as well. These larvae are moving. So like it's worms that are moving. So they usually sometimes eyeball it and then just put about 5,000 in each cage. So this particular project work for them is to be able to use computer vision to identify the larvae and then also estimate the count. Right. So with this, they were able to use to automate the process of counting and identifying the life. So that kind of speed up their process. And then there is currently an ongoing project as well in the healthcare sector, which is ocular disease detection. So there's been a lot of research about the nature of the of your retina, right? So with an aided device, you can capture an individual's retina and then process it through computer vision to be able to see if there is any disease. And the research shows that you can use it to detect, let's say, glaucoma, diabetes, retinopathy, cardiovascular diseases. So we're currently doing a pilot project here in South Africa to be able to do that. So with that device, so you attach a particular device to, let's say, your phone, and then you capture the retina, and then we process the image through the platform. That's we can then detect if there's any disease in the particular image. So also a bit more of our platform. So as I mentioned earlier on, it's beyond agriculture, because computer vision have applications in various sectors. So in the retail, you can use it to basically count your stock, identify the various items on your shelf and all that. Then with manufacturing, you can also do defect and quality control detection. So you can use it to identify defective products in your production pipeline before your product, goes out into the market. And we have a case study already on the healthcare, and then with also mobility, and this is very quite common these days. We see a lot of self-driving cars and all that, which incorporate computer vision models. So the application of computer vision is endless. It's more like aiding the computer with kind of the human eye. And so with the human eye, we can do a lot. We can see, analyze and do a whole lot of, stuff with that. And with healthcare, there's also a lot of research showing that AI medical screening are more effective than, radiologists. Because mostly as a radiologist, I spoke to a radiologist recently, and in their day-to-day active workload, they could process about, let's say, 100, medical images. And sometimes when fatigue sets in, they are prone to making errors and all that. But with automated AI solutions, that can actually help speed up the process. So the AI can handle and automate all this analysis, and then just, give it to the radiologist just to approve or like to review it. So this kind of, work, it helps with augmenting the human workforce, not going to replace them though, but to augment and make our workforce more efficient and faster. So I'll move on to the computer vision pipeline. So this is the pain points that our business is trying to solve, right? A lot of computer vision projects is time consuming, and then because you need to do a lot of iterations, a lot of coding, to be able to train a model, and then also setting up the infrastructure after you've trained the model to like taking it into the market or to the production environment. It's also a whole different thing altogether. And so we see that a lot of computer vision projects just end up at the prototype stage. It doesn't ever get into production. So that's what our platform is solving, right? So we provide you with a platform to be able to manage your data set. So that means you can capture your images from the field with just your smartphone or a camera, and then upload your images onto the platform. And then the next phase, which is the more tedious and manual process, is the annotation. So annotation here means you draw bounding boxes around the images of, so trying to identify the object of interest so that the AI can learn from it. And then the training process involves writing your AI algorithms to train the model. And then after training, you also then have to evaluate. Evaluation state, tells you if your model is good to be used in production or not. And then deploying is taking it into the field. So either you deploy it through, a mobile app or an embedded device that can be attached to a drone or, or in cameras or anything like that. So we'll go much deeper into what our platform provides for each of these steps. So first of all, so this is how the data set preparation for object detection is, right? So what is essentially we do here is after we collect the data from the field and upload it to the platform, it's just images, right? But we need to let the computer know, or the AI model know, what we are interested in. Okay, so that's kind of gives us more flexibility, right? So every business or maybe every project has its own, goal or what you are trying to reach. So with the object of interest, you just label the images. Okay, so that is what the whole annotation process or labeling is. So this is an example of how the labeling looks like. So for this particular image, you can see that we've drawn bounding boxes around the ripe tomatoes and then the unripe tomatoes. So these bounding boxes are like coordinates on the image, which will be fed into the AI model, so that the AI models, when it picks this particular coordinates, it knows that, okay, this is a ripe tomato and that this is unripe tomato. So that's what this whole process is. And in general, in most cases, this is done manually, right? So an expert has to sit down and label the data to ensure quality. Okay, so let's say in the case of our Agric sector, you probably have an agronomist who are trained experts in identifying, let's say, diseases or pests in your crop or your farm. So once you have that images uploaded to the platform, your agronomist will then come and then label it. They can also show your team what to look out for. So there are a lot of this is a whole business on its own, where people are trained to be data labelers or annotators. And then aside as providing the platform to be able to annotate, so you can annotate with your entire team. You can invite your team onto the platform and annotate. We also provide you with auto labeling tools. Auto labeling tools is an advancement that has been made in computer vision sector. So what that means is that after I've annotated, let's say, about 10% of my data, so assuming my data is about 10,000 images that I want to use to train the models, what that means is that a human being has to sit down and annotate all these 10,000 images, which is very time consuming. Because aside it being 10,000 images, assuming that what each image has about 10 or 20 bounding box. So you could then estimate how much time you spend annotating it. So our platform provides auto labeling functionality. So let's say you are able to annotate 10% of your data. You can then quickly train a model right from the platform and use that model to annotate the remaining 90% of your images. Then we have a review process that you can then, what you'll just be doing is to review and go through it to ensure that, okay, you are happy with the annotation provided by the auto labeling. And then you can then use your entire data set to train your model. We also have auto labelings that are models that are general purpose. So for cases where it's very peculiar to the business. So assuming that you are working on a particular species that is not available in the market, right? There won't be any model to automatically, auto label it for you. But assuming that you are working on the sector where there are models available. So for example, let's say you are working in a model for in the urban mobility sector to, let's say, identify pedestrians on road, vehicle types and all that. The auto labeling, we have models that can do the general purpose labeling. So they can identify, let's say, human beings, cars, bikes and stuff on the street. So all these models are available to ease the process of the labeling for your team. And then there's also after labeling the data, the next stage is configuring your data set prior to the training process. As I mentioned earlier on, after you train the model, what you essentially need to do is to validate it. But it is a general process in training all AI models is to split your data sets into different, types. So you have the training sets, the validation, and the test. So all this is automatically configured. So you just need to specify how much you want to split your data, right? So the idea is that you want your model to be trained on, let's say, the 70% on a training set. So the model doesn't see the validation set. What that means is that the model should be able to train and then generalize on real world data. Okay, so that's the whole purpose of train validation test plates. So you cannot, it's like going to write an exams and then you already see the exams paper, right? So the model, if you train your model on all the entire data, so what that means is that your model has already seen the exams question, so they can easily answer. But in the real world, you don't see the exam questions before you enter the exam hall. So that's the approach. So you learn on the training set. So that will be your lecture notes, and then you go and face the exam with that's the validation set. So what in the training iteration, it's kind of does several iterations to train and then validate, train and validate, and the model keep adjusting its parameters to be able to then perfect or recognize the patterns in the data. And then another thing that we also offer is augmentation. Augmentation is also very useful because one, you want a model that generalizes a lot. So when you talk about generalization, is like, for example, you train a model that is only useful in, let's say, in your farm, but you want to be able to make that model useful in another farm, right? That model might not generalize and perform well in another farm, okay, because your data set is less, there's less variation in your data set, right? So in the manual process, you have to go and collect more data, more varieties of your images. But there are also automated ways that you can use that to generate more variations of your image. So that's what augmentation is about. So let's say you take one image, and it also helps to mimic the real world environment, because when you take a camera about from two different brands, iPhone and Galaxy, the picture quality may be different, the lighting may be different, and then maybe if we are using, a low-end phone, there will be more noise or blur, right? And then also different lighting environments. Maybe the time that you are testing your model might be in the morning or late in the day, which lighting might not be good. So this process helps you to create all these variations. So you can, and then also camera angles. So that's where rotation comes in. So let's say you pick a normal image, you can then let the platform create variations. So it rotates some of the images, it flips some of them, change the perspective, the brightness and crop and blur. So there are a whole lot of configuration. So this creates more variations for you, and then also increases your data set, right? Because coming by data set is not easy. It takes a long time to be able to build up a data set of, let's say, about 10,000. But with augmentation, assuming you have 1,000 images, you can generate more variations up to 5,000 or 10,000. So that gives you a very comprehensive data set to train your model. And so the good news is that all this is available on the platform. So with just a click, you then configure or choose which augmentation, that you want to apply, and it will generate for you. And then you can also choose the size. So let's say you want to create ×2 or ×5 of a data set. It will then just create all these image variations for you. Then the interesting part is the training process. So this is where you take all the data sets you've prepared and then feed it into the AI model. So this what the AI model is doing here is try to recognize patterns in the image and associate these patterns to all the labels you've done, right? So in the case of the ripe and unripe tomatoes, so the image model is going to learn and pick features from ripe tomatoes and then unripe tomatoes. And then in this whole process, we want to measure how the model is learning. And then when after it learns in one iteration, we then compute what we call the training loss, or in a broad term, an objective function. So in AI training process, we always define an objective function. So that is your objective, the goal of the model. So what the model should learn and how you're going to grade or assess the model, what the model is learning. Okay. So let's say you do your first training and then you do your calculation for the objective function, and let's say it's high, but you want to bring this to low, because what you are trying to do is to for example, minimize our errors. So in every objective function, there is the direction. Either you minimize or maximize, right? But for object detection models, you usually want to minimize the errors. Okay, so that's why here we see the curve going down. So this is the loss function is determined based on the task you are working on and the model, right? So in this case, you want to see a loss function, a loss curve that is going down. What that means, you are minimizing the errors that the model is making. So this whole process is more like a training loop that keeps on training and going on and going. So sometimes, depending on how the data sets, the size of the data set, it can take hours to be able to train. And because you want to have a near zero loss value for all your models. So all of this is also computed on our platform. So the moment you click train, it takes over, done all this training loop, and then outputs the metrics for you to see. So on our platform, we have the models we are using currently is YOLO model. So YOLO is a popular object detection model. So you can research more about if you want to understand the theory behind. So it's open source and available for everyone to use. So you can, you don't have to, worry about any licenses or enterprise fees. And then we also have, we use GPUs. So GPUs are more, advanced computing resource because most of these models require a lot of computations. So doing it on a normal CPU is not very efficient. It takes a long time. So our platform provides you with the GPU instances to train the model, which speed up the process. And then we do have a lot of, other configurations like early stopping. So early stopping is usually when your model is overlearning, right? The training data. So let's say your model is learning and one is overlearning. So it's more like generalizing more on the training data and not able to do any meaningful predictions on the validation set. So you stop the model when you notice that. Okay. And then also if let's say your training, the loss function flattens. So as it's going down and then it flattens, there is no, decrease anymore, which means there is no kind of time to, continue training. It's just going to waste more resources. So you then also stop it. So this all is configured on the platform too. So more or less all the configurations that as a researcher or, a business you need to worry about and write all this code is automated on the platform for you. And then the evaluation stage, this is also very critical. This because if you train a model, the next thing you need to do is evaluation. So that's why most of the time, like even with these GPT models and cloud models, by the time they release, they do benchmarks and they say, yeah, this is much better than the previous one, or this is much better than this other company's model, right? So there are lots of evaluation metrics for different models, for different, tasks. So when it comes to object detection, these are the main metrics that we look out for. And this is also all computed on the platform. So as the model is training, it's computing the training metrics and the evaluation metrics for you to see. So the first one is the precision. So so without going too much technical, but you can read about all of this available. So here we are just looking out for how, of everything that the model flagged as, let's say, disease, how much was actually disease. Okay, so more like you are looking for the true positives, right? And then with recall, you are looking at of all the disease that were in the data sets, how much did the model catch? Okay, and here we also compute in object detection. We have this because after we do the there are more like two main tasks. So the first is identifying the label to say that, okay, this is ripe tomato, this is unripe tomato, right? And then it's also trying to find all the bounding boxes, align all the bounding boxes. So in this case, you have the ground truth bounding box. And then it's also trying to predict the bounding box so that we can locate where the object of interest is on the image. So this is unlike classification model where the AI model is just classifying the entire image. With object detection, it's identifying or finding the location of the objects in the image. So it's more or less doing classification tasks and then localization. So trying to find the location of all your objects of interest. So here too, we compute what we call intersection over union. So that is more like the union of the bounding box for your ground truth and then the prediction. Okay, so this is also computed. And then the main overall metrics, that's mostly, if you look at a lot of object detection models, they will quote MAP, that is the mean average precision. So more like this is like an average of across all the classes, and then you know, and it also takes into consideration the precision and the recall. All right, so it's more like an area under the curve function. So you have your precision and then the recall on the axis. So here the idea is that you want to be able to have this mean average precision close to 1. That means a perfect model. But in general, any metrics over 70 is ideal. So that is 0.7 anytime. So if you're able to train a model and you're able to get mean average precision of 0.7, it means it's production ready. You can use it. The reason why you may not be able to get a perfect model is mainly because of the bounding box localization. Because if your ground truth is this and the model tries to predict, most of the time it's not able to predict exactly on top of this bounding, your ground truth. So there are small margin of error here allowed here. But in terms of the precision wise, that is, if we're able to get the classes predicted correctly, that is also great. Then after training all the models, the next is deployment. This is also one challenge. And in most cases, you would need a very technical person, a machine learning or AI engineer, to be able to deploy your models for you. And it will also require a very expensive infrastructure, because because in production also you want your models to run on GPUs, which are expensive cloud infrastructure to pay for. So as a business, if you don't have to worry about all this complexity and then the cost burden, our platform provides everything for you. So we have various ways you can use the model in production. So you can use it via an API. So an API is more like a URL that you can then just make a request to that particular endpoint with the image that you want to predict. So we've provided an SDK that you can integrate into, let's say, assuming you are building a mobile app, you can integrate it and just make API calls to the mobile app. And then assuming you want to also download the model weights, right? So these are the weights are more like all the parameters that the model learned from your data set. So it computes all these weights and we store it for you, so you can download it and also run it in whichever way you want. And then we also have this different export formats, which is the ONNX runtime. So these are model weights. So it's also a model weight, but in this particular format, it's optimized for edge devices or mobile phones. So you can easily run this on your mobile phone. So if you've been following the AI trend a lot of these days, we have some of these models. So even ChatGPT, we have different versions. we have GPT, and then the mini version. So most of the time, these are optimized to run with limited resources. So let's say on your mobile phone, you can run it offline, right? Because assume if you want to run the, the large model, you will require more computing resource. So you probably be forced to deploy your model on the cloud. But with this format, you can run it offline in let's say Raspberry Pi or NVIDIA Jetson, or even in the browser. So it's more like an optimized version. So the platform provides these versions for you as well. All right, so this is the end for the presentation. We'll move on to the demo. But if you have any questions on the presentation, you can ask now, and then we'll quickly move on to the demo after. Okay, since there's no question, I'll move on to the demo of the platform. Okay, yes, so
just a minute before you
okay,
go ahead
sure.
with the demo, I would want to say that if you have a question but you can't talk looking at your environment, you can just put the question in the chat and I'll read it out to Philip. Okay, thank you so much. Philip, you may carry on. Thank you.
Okay, thank you. All right, so our platform is Epigos AI. So if you go to the platform, if you check it now, when you create an account, it will take you to a dashboard like this, right? So we have a demo project here. So that's why we have all these different AI models we've worked for demonstration purposes. But so if you log in, you will not see all these projects. So what you have to do is to create a new project. So the project is more like an isolation of that particular task. So you can have multiple projects. So assuming you want to do, different tasks which are not related to each other. So you can create multiple projects for it. So I'll just go through quickly and then demonstrate some of the projects we've done already. So assuming that you want to do a tomato disease model, and then so our platform also, you can also do image classification and then object detection. So for what we discussed today is object detection. Then you can then continue. Okay, so predicts, here's the description. And then here you can provide the labels, but I'll skip that. We can add that later. Then you create the model. So you create the project. So once the project is created, you can then go to the project. So this is the project interface. With this, you can then first of all create your label. So as I said, the labels are more what the AI is going to identify. So let's say in the tomato disease, there are different labels or diseases that will be identified. Let me go back to the existing project. That will be much clear. So we already have project that we created for demonstration purposes. So this particular, so this is also the tomato disease that we're going to talk about. So these are all the labels. And agronomists will kind of know all of these things already. So these are diseases are found in the data set which they've labeled. But for so this particular tomato disease data set is an open source data set that's available for research purposes. So it's not meant for commercial, but I think there's a license to use it commercially. But to clarify, it's not an internal data set that we created ourselves. Okay, so these are the labels, and I will later explain this as well. And this is so when you create your project, the next phase is to upload your data set. So the data set upload is in many forms. So you can upload it via the the UI. So here you could, let me add just small data set here. So assuming this is my images, right, I can easily upload it here from, and then you can also have a notebook that I'll also go through to show you everything. So the process is quite easy. So you can upload thousands of images here. Once you are done with the upload, the next thing is annotation. All right, as we discussed in the presentation. So when you click on this, so you can easily start annotating the project right from here. And then you can also see the other tools we have, the auto labeling and all that. So here, if you click on this, you will see the annotation interface. So here, you have some tools that you can use here, right? So the main tool that we're going to use in object detection is the bounding box. So the bounding box, once you click on the bounding box and then you draw a bounding box around objects of interest because you feel like this is a disease, and then you choose what type of disease it is. I'm going to just choose a label for demonstration, and then you pick it. So you see all the labels you've done here. And there are tools that you can use, but our platform does helps you to do everything in the cloud. So you can collaborate with your teammate. So you can, after you upload your data set, you can invite your teammates to also join with the labeling, right? And as you can see, this can be very tedious because assuming how to do this if there are lots of, objects of interest in this particular image, I have to go through all of this one by one. So it is a very tedious process. And also you need an expert because as I'm labeling, I don't know if this is actually what the disease is because I'm not an agronomist, but you need to be trained to know what to do. So in most cases, you need to have an expert's guidance when annotating it because even in the Agric and healthcare, assuming you have to annotate X-ray images, so that's require an expertise to do that. So it's in a way you put in all the expertise into a format that the computer can then learn and understand the problem. So I'll just delete this once. I will have a demonstration of the auto labeling as well. So here, these are existing models we've trained for this particular project. So we can select it and then let it auto label it for us. There are also other models. So these are open source models, right? So Polygerma is an open source vision language model from Google, which you can use to auto label general objects. So like cars, people, bikes. So assuming the problem you are working on is to identify, let's say, people, cars, and stuff on the street, you can use models like Polygerma, and Florence is also a model from Microsoft. And then Grounding Dino is also a model from Facebook. So these are open source models that you can use to facilitate the labeling process. But most of these general models might not be peculiar to your task. So then what you have to do is to label a small subset of it, train a model, and then use that to do the labeling. So I'll demonstrate that here. And most of the time in labeling, you wouldn't need a high precision, so you can lower it to get more labels out of it. So when you click, it takes the image and then run it on through the model and then label it for you. And then once the labeling is done, you can then approve it. So let's just wait a few moments. Okay. Yes, so it has returned the labels. So here you can see that it provided us label for this one. When you click on this lead blight. This is black spots. This is lead blind. So this is how easy the platform is. So this can help facilitate, and you can do it in badges, right? So I'll show you how the badge is done. So you can just after you uploaded all your models, all your images, you just click to label the entire batch, then it will do that for you. So since I'm happy with this, I will just click on approve, and then it will save it for me. Then that is it, I'm done. But we can then go through the batch process. So assuming this, okay, this is already labeled. But with the batch process, you can just click on the auto label a badge, right? Then you choose the model. So similar to what we just did, and then it will just do that for you. Okay. So it will be running, and then once it's ready, you can just go and approve it. So once we are letting that run, go through the other sessions. And so this session shows you all the data sets you have uploaded. Okay. Okay, there's a question, Benjamin, but you can go ahead with your question.
Yes, so my question is with regards to labeling. So let's say you've automated the labeling part as you've done now, and then you also train your model, and then in evaluating the predictions that the model makes, let's say you realize that maybe on the edges of the leaf, it's been making, let's say, a form of mistake of classifying the edges as black spots. Can you go back? Is that also, is the labeling also part of the iterative process where you can go back to like go and make changes and then go through that whole process again, or is the iterating part only regards to the training and evaluation onward?
Okay, cool. That's a very good question. So the model auto labeling using an existing models means that you've trained an existing model on a subset of the images. So it goes through the iteration part to train the model. But after it has finished labeling, let me see if there is, okay, it's still running. After it has finished labeling, there is a process for you to review it. Okay. Since you are automating it, ideally, you want to be able to review it and make sure that the labeling is correct. Okay. So with this process, you can do all the corrections that you want to do in your data set. So even though we provide you the automation of the labeling, in your own process, I think that you still need the expert to review all the images. But the review process should be faster because you are not drawing bounding box. But you can, let's say it did a wrong labeling, you can easily delete it and then just approve. Or when you delete it, when you save, it will be removed from the database. Does it make answer your question?
Yes, it answers my question. Thank you.
Okay. All right. So yes, so with your data set, you can see all the data sets you've annotated. So this is already annotated data set. Then the ones that are not annotated, you can have all of them here. Then after preparing your data sets, we also have some insight metrics we provide. And with every model, so the whole understanding is, or the general knowledge is that garbage in, garbage out. So the best data sets produces a more intelligent model, right? So if your data set is not great, you are not going to get a good result. Okay, so we provide you with some metrics to help you with how your data set is looking like. So here we see all the images that's available and the ones that are not annotated. And these are just general images. So like, it's the average megapixel of your images. Ideally, you want to have a high quality images. And then another thing that also affects the model is the distribution of your labels, right? So as you can see here, we have a lot of early blight, they're followed by black spot, late blight, and then the healthy ones. these ones can be problematic because we don't have a lot of instances of it, right? So it's just like a disease that is very rare. You don't know much about it. So more or less learning about it becomes difficult versus one that's very common. So this affects how the model tends to be biased. And if you've seen a lot of people talking about model bias and all that, and even in a lot of these AI models that are out there, some of them are biased towards minority race because they don't have a lot of data about them. And in some cases, it will discriminate the minority labels. So that's what is going to happen here. So that's what we provide you with class balance. So here it tells you that early blight is overrepresented. So what that means is that the model will be more biased towards early blight because it knows much about it. Okay. Ideally, you want to have a balanced data set. So black spots and late blight are great because it's more or less balanced. But these ones are underrepresented. So they will be discriminated most cases. There are ways to go about it. That is how you probably adjust the model weight and all that. But in the best approach is to either have more images that kind of balances it out, or with the augmentation process, you can also use augmentation to upsample these minority classes so that during the augmentation, it will generate more of these classes. But even if it's few, it's still going to be more like the same thing, that is having multiple variations. So yeah, but there are other techniques around it to be able to do that. And it's very quite common because I remember when we were working on the cold disease, there were other diseases that we were looking at, but we didn't have a lot in the field. So we had to drop those diseases. So yeah, that's one note. But so in our platform too, you can then choose after you are certified and want to train your model, you can exclude these labels from it in case you feel like you are still not able to get a lot of it. So let's just go to the training process. So assuming we are fine with the data sets, we'll just go to train the model. So you click on the training button, and then here you see all the labels. So as I said earlier on, you can say, let's say you don't want to include the minority classes. So you just select these ones to train the model on. So which means this will be excluded from the model. Then you move to the next stage. So the next stage is the validation split. So here you can also choose how you want to split your data. So the training set is what the model will train on, and then we'll validate it against the validation set. So I'll choose 80%. And then this is the augmentation process. So first of all, we can select the augmentation steps, right? So this is all the variations that we can create for you. So you can change the color, saturation, add some noise. And then with the noise, it's also quite configurable. You can choose the threshold and the magnitude of the noise you want and all that. So assuming I'm just going to use this for demonstration purposes, but just you can choose different ones, choose different brightness, lighting condition and all that. And then here in this case, you can also then choose the number of images to generate. So we want to generate ×2, ×3, so all the way. So in our initial data set, it was about 800, but we can generate up to 6,000 ×10 of it to give you a more variable data set. And then the next stage is also choose the model size. So these are different versions of the model, right? The first model is kind of very optimized, smaller model. So it trains quickly, but it's less accurate. So you want to do quick prototypes or even use that for the auto labeling, you can just choose that. But when you are ready to go into to production, you want to use the more accurate model. It's a larger model, so it takes longer to train, but more accurate. Then after that, you just, this is just a review of all the configurations you've selected. So you can just click train. If you're happy with it, you just click the train, and then it starts the training process. So depending on the data size and the server load, it can take some time, probably 30 minutes to hours to train, because it also goes through the whole valuation and the training loop to make sure the model is good enough to be used in production. So for the sake of time, I'll let this one be training. Let's see. Okay, yeah. So let's go back to the letter auto labeling is complete. So you can yeah. So this is all the one we did auto labeling. You can approve the entire badge from here, or you can go through it manually and approve it. Okay, so like this will take you through the images one by one, and then you approve it. So that's how it looks like. So that's answers the question to this one. So it's saved. Yeah. And let's show you some of the models. So these are the previous versions. So anytime you train a new model, it creates a new version for you. So that you can you choose to use whichever version you want. Okay. So here, these are all the models that have been trained for this particular project. So you see all the labels that was used for this model. And then for this particular one, you see the number of images was about 1,008. The actual images was around 700, and we added augmentation to get up to 1,008 here. And we could see the difference in the accuracy. Even a small margin is very useful. So this particular data set was about 700, but when we did another iteration with augmentation, the accuracy is up about 95%. And here you can see the training metrics. So these are the metrics that I went through. So the training loss, and then the so the training loss. So for the box, I told you that for object detection, we are doing localization and then classification. So localization is identifying all the coordinates of the bounding box so that it matches the ground truth data. And then the classification is after we identify the location, what object is there, right? Is it, let's say, ripe tomato or unripe tomato? So that's what it is doing here. So you see all the logs here, and then the position, which gives you all the true positive, and then the recall and other. And then so the top ones are the training metrics, and then the validation metrics are here. So always, depending on your objective function, you always want to, if you are minimizing the loss, which in most cases, if we are dealing with loss, it's minimization. So you want to see this line go near to 0. So yeah. And then you can then also go through. So when you click on the details, you see all the model details, right? So the data set that was used, the labels, and then augmentation. So these are the configuration. And then these are the metrics. So the mean average precision is about 95 for this particular model. And then the precision and the recall is also here. So the good side is that after the model complete training, it deploys it into our inference server. So that means you have access to use the model right away. So we can try this model right now, uploading an image of the tomato. And then we can just use a lower confidence threshold to see everything that comes. So the confidence threshold, if you use a very high confidence threshold, it can filter a lot of it out. But if you want more, it depends on the tax you are dealing with. Mostly with medical analysis, you want to have a higher precision. So you probably want to use a higher confidence threshold. Okay, so this is the outputs of the test. So here we see all the objects that have been identified. So you can see each object and then the confidence threshold for it as well. And then the counts. So this is also useful for you, assuming you want to do counting. It aggregates the count for each label for you. And then this is just to test it in the dashboard. But assuming that you want to share it with people, so with this, you can use this link, and anyone that has have access to this link can use the model. Okay, let's say it's loading. Yeah. Okay. And so this is for, you can, after you train a model, you want to share it to anybody. They don't need to log in to use it. So assuming you have a team or you want to share it for people to use it, you can just, copy this link and then share it with them. So here you can easily use the model here as well. Yeah. So you see all the detections done here. Then we have the SDK. So if you have a developers that you want to connect this to, let's say your mobile app, so you can use the API directly, or let's say if you are using Python programming to build your app, you can use that, or you are using JavaScript, you can use the Node.js SDK. And then these are the formats available. So this is the PyTorch. So it's in YOLO format. So which means any library that can run YOLO models, you can just download it and use. And then with this, you can also integrate this into let's say a mobile phone or Raspberry Pi to do the same detection. Yeah, so this is let's see if the model has finished training. So the training process is still ongoing. So probably have to wait for some time. But aside that, this is how the whole interface looks like. And also, we have different data set versions. So anytime you create a new model, because you choose different configuration, it will create a new set. So this is the data set we just created. All right. So it has, which means it has completed the augmentation, right, and everything. And that it has done the splitting for you, the training and the validation split for you. So you could see the ones that are augmented. So you can see, so this particularly is a noise that has been added to this image, right? So yeah, some of the images have been flipped, some brightness and all that. Yeah, and then yeah, so this is the demo for the platform. If there's any question, then I will show you a small notebook on how you can run it via the SDK, the Python SDK. Do you have any questions? Is anyone having any questions?
I think there's a question in the chat box. Does Epigos AI work offline? That's a question I think someone was asking.
Okay, so the platform itself is cloud-based. So in your annotation, the training process is all done in the cloud. But you can use your model offline. So we provide you the option to download your model and run it offline. Okay, so that is the option we have. So you can, if you download the PyTorch or the YOLO weights, you can run it on your computer or any other devices that can run. And then or the ONNX formats can run on mobile devices or Raspberry Pi or any other, NVIDIA Jetson or anything like that. Yeah.
Okay, there is
Okay.
also a hand up, so you can ask your question.
And okay. Okay. Yeah, you can go ahead.
Yeah.
I wanted to know, I don't know whether you mentioned it and I missed it, but I wanted to know for the auto labeling, do you allow for a bring your own model type of operation where somebody can have maybe a pre-trained model and would want to use that for the auto annotation of their images? So do you allow people to bring their own model?
Okay. All right. That's a good question. Currently we don't have that. But I think it's something we can support. It's actually we can create that feature for you if you want. We can add it. Okay, that's there are more hands raised.
Yes, I wanted to ask this since I find myself in the university dealing with students and all that. Now we have, or we are in an era where it looks like people have so much time, and at least they could spare a couple of hours or some minutes to do some of these annotations. Yes. So how can a platform like this, right, take advantage of that vast workforce that we have, let's say students, right, who some of them might have the capabilities to do this at a fee. You get it? Yes.
Yeah.
Because there was a project that I was working on some time back, which is also annotation, but towards that angle. You get it? So I believe that your platform is matured, and at least if you try to also look at that annotation as a service, it will be better to get students also, like, or if not students, even practitioners in the field also very interested in coming on board and contributing their quota. Yes, so that's just a suggestion that I'm looking at, which I feel would really get the community all out for this. It's a very good tool, actually. I'm very impressed about it. Thank you.
Okay. Okay, thank you. I think that is really a good idea. We've had that thoughts in the past. I think yes, everything that you said is valid. Annotation is a whole business on its own, and a lot of people are actually doing this to earn a living from it. So I think it's something that we'll add to our plans actually, and then we'll incorporate that, and then so that we can then offer it as a service as well, so as a separate service. Because of how so currently the whole process is matured. So let me show you the team. So assuming you have you want to add a lot of people for this particular project, so we can invite people. So you give them admin access and then the labeling access. So what that means is that these people can only do labeling. So we will actually consider that and add it to our plans. Thank you. And yeah, so I'll reach out to you and then we'll see how we can also get the students involved. Yeah. Okay. Any
Okay,
yes.
sure. That's good.
Yeah.
All right. First off, I think this is a very good one, and I'm particularly happy about the fact that it is coming from Ghana. But I have maybe some few questions. The first one would be the types of crop diseases that Epigos AI can currently detect. So what types of crop diseases? You showed tomatoes in the demo. I don't know if you have any other crops in there and the diseases that they can detect.
Okay. Yeah, so it's quite flexible. So for this particular data set, these are all the diseases that are available in this data set. So it's quite configurable. So you can add more labels. So we have unlimited labels you can add. So it all depends on the data set you have. If let's say your data sets have a lot of different types of diseases, you can include all of them and label it, right? So you don't have any restriction on the number of diseases you can detect. It's only the restriction is only limited to your data set. Okay. Yeah. So I can show some other projects that's okay. So this is okay, this is not disease, but okay, so let me not move away from the okay. So this is a livestock project we did. It's not for diseases, but it's identifying livestock. So working with a company in Nigeria that wanted to use this to count, first of all, count their livestock, right? And identify the various sizes as well. But eventually I wanted to also include diseases. But this shows you how versatile the model is. So for example, this one particular one, it's identifying the cows on the field, and then you can, so the label, what I want to show is that the labeling is quite flexible. So in this particular one, you just identifying the cows, but assuming you want to, let's say, include pig, you can just add more, let's say goats, add more. And then if it's a disease type of data set, you add the diseases here, and then you go on into the data set and label. Okay.
All right. So my next question will be the images that I would want to upload. Do they need to have some minimum resolution? Or that
Okay.
doesn't matter?
Okay. Yeah, it matters. In most cases, you want to have a very clear image. But currently, even a lot of the images from phone are still usable. So you can still have let's say a minimum of, let me see this particular project. This has very small images, I think. Yeah. So this particular one is a blood histology project. So it identifies various types of blood cells. But you can see the resolution is not that great. And the size is also small. So there is no kind of a rule around it, but it more or less kind of use your best judgment to see if the image is clear enough to be able to, for anybody to identify.
All right, thank you.
Yeah.
So, Abdul Malik, we are ready for your question.
Yeah, about the data augmentation, I wanted to know if it can be used to sample the minority class or just the class balance approach is enough.
So yeah, so currently the platform is not doing the upsampling. So with the augmentation, it does a general augmentation on all the classes, right? We are still working to incorporate upsampling the minority class for you so that you can then choose whether you want to upsample or downsample the majority class.
Okay, thank you very much.
Yeah.
All right, Mary, you may go ahead with your question.
Okay, thank you, madam. I wanted to ask if the platform is for only prototyping or you can use it for production. That's my question.
Okay, it's not for only prototype. So you can use it in production. So let me show you. The model is ready. The platform is ready to use in production. So this is for when you want to test your prototype. Assuming, let's say, you work in a team that wants to or you have access, you just copy this link for them to use, and they have access to this to use it in production. So let's say in your lab or whichever work setting you have. And then when you want to integrate this into let's say a mobile app, right? You can use the API. That is if you want to run it in the cloud. So that means that the phone has to always to connect to the internet. you can use the API or the Python SDK or JavaScript SDK. And then you can also run it offline. Okay, so what offline means you download this model weights, add it to your mobile app, and then the model can start doing making detections with the mobile app. It doesn't need internet connection at all. Yeah.
Okay, thank you.
All right. Any more questions? Okay, so if there's more question, I'll just, okay, so this is the API documentation you can use if you want to integrate the API. I also prepared a short notebook so this is the data set. So as the data set we use today is on Cargo. So this particular data set. So this notebook shows you how you can use the Python SDK basically to do. So if you are have a bit of programming knowledge, you can easily run this notebook. So I'll quickly run it to see. So basically here, this, okay, let me just run the notebook. First, we download the data set from Cargo. Right. So if you have your data sets in, let's say, your Google Drive or any other formats, you can just connect to it and use it. So the data set is downloaded. So this shows you the data. So this particular data set has already been split into, yeah, so you could see that it's been split into test, train, and validation set. So that's the folders we are seeing here. And if you look at the Google Colab, you see the data set is downloaded here. And then, okay, there's a question from Justice. Just you can go ahead. So I'm installing the SDK, the Epigos AI SDK. Justice, you can go ahead with your question.
Okay, thank you. So data on any other cloud, the system allows me to just connect to it directly without pulling it down.
So currently you can upload the data via the API. So here, to go to the upload, so we have an API. You can use that to upload, or there is, you can also use the Python SDK. So let's say the data set is in YOLO formats. You can just download it locally and then upload it. But I think it's also a valid idea to be able to connect to, for example, to pull the data from Cargo or any other platform, like a URL that you can just download. We will add it to the platform. Okay. Yes. So going through the notebook. So I've downloaded the data set and I've installed our SDK. So I can then just, so this is just the classes that is in the data sets, the number of images in the test folder. So I'm just going to visualize one of the images from the data set we just downloaded. So this is the one we just downloaded. So with Epigos, you have the access to generate an API key. So let me see here. Okay. Yeah, so you have API keys you can use. So if you are connecting from your third-party app, like mobile app or anything like that, you can create multiple API keys. And then you also take note of the project ID, right? So be able to use it. So that's what we have here. So we have the API key and then the project ID. So this is showing you how you can upload from your, after you've downloaded the dataset. So we can just test the upload from the API. So I've named it as badge. The badge name is, okay, I think I need to restart this one. Okay. I think there's a compatibility issue with this particular line. Okay, let me try again. Yeah, things working. Oh, now I think let me just restart the kernel. Again. Just rerunning the notebook. Yeah, Ali, you can go ahead with your question.
Yeah, it's a really brilliant platform, and as our moderator said, we are very happy that it's coming from Ghana. So we are proud of the system and the implementation. There's one thing I want to suggest. I think you have all the ingredients to have an MLOps type implementation documentation. Yeah, so it will be very nice if you have that in your documentation. You have the ability to be able to engineer data from a source, maybe an S3 bucket, directly into your platform. You train, you deploy, and then you retrain. I think that the part that is a little missing is the process of doing the retraining after deployment. If we can have that loop closed, then it is going to be a self-reliant system, like an MLOps based system, and that would really be brilliant because a lot of in the industry, a lot of people are interested in this MLOps loop. The second thing that I wanted to talk about was data privacy. Because data sovereignty is becoming a very big thing with AI eating all our data. So if you can put in your documentation an assurance to people, especially businesses, that you have a very solid either support for GDPR or you have support for our local data privacy model type of thing. I don't know what is happening in Ghana, but I believe there's something like that. That would also be a very strong leverage that you can tell a lot of businesses that, yeah, I'm taking your data to train your model, but I'm not either keeping your data or I have a way to support data privacy models. And then the last thing that I wanted to mention was about MCPs. I have been working with AutoML design. And I realized that with AutoML design, if you can have an MCP connector to your backend, you really can help a lot of people who are now using agents to do model training. So if you find a way to include MCPs within your system, I'm not a fan of MCP, but it seems like for now that's the only way we can interact between agentic systems and tools. So that is those are the three things that I wanted to mention. Brilliant work. Thank you very much.
Okay. All right. Thank you very much. These are very good ideas. I've taken notes of them. Yeah, I think we can, it's not a big deal. We can have all these systems. And then, so for the model training version, I think is something that we can still cooperate. So currently there is only manual trigger to train the models, but we're looking at adding more features in terms of being able to trigger retraining from API calls, or maybe measuring prediction drifts and then trigger, like making suggestions and then trigger the training process. That's thanks for the ideas. And then the data sovereignty, yeah, is also a major concern. We try as much as possible to keep your data private. So currently, nobody should be able to have access to your data. And then you can also delete your data sets. You can request for deletion of your data sets as well. So that after you train your model, you can then delete everything. And yeah, and the MCPs, I think it's also cool. It's something that we can accommodate. We're already thinking of how we could incorporate agentic AI into the platform. So we'll surely have that implemented. Yeah, there is one more question from Gladys.
Yes, Gladys, you may go ahead.
Okay, thank you. Please, I want to ask that how does the system handle poor image quality or low light conditions in rural farms?
Okay, so that's a very good question. So if your data sets, that is where we have the augmentation here. So with the augmentation, you should have a variation of some of the images that's of low quality, right? So the first of all, you want the model to be able to generalize on all possible scenarios, right? So low lights, highlighting, noise, blur, like maybe images captured from low-end phones and all that. So even if your dataset don't contain these variations, the augmentation process will generate this variation for you. So what that means is that the model should be able to learn from some of these scenarios, right? Aside that, I think for this particular, so most of these models work on a pixel level. So sometimes the human eye may not see a lot, right? But at the pixel level, there is more details in there for the AI models. So I think that it's currently it's not a major road block for it to run in situations where the phone is low end and stuff like that. That's something that we could research and see how that performs. But in most cases, it's able to handle those situations.
Okay, thank you.
Okay. Yeah. So so I'll quickly go through this. So I've been able to use the SDK to upload, so we can see this is the one I just uploaded. So this upload already contained the annotations. So when you run so if the data is already annotated and you upload it, everything goes in there. It goes with the image and the annotations all in there. So this is what we have here. Some of the ones we recently uploaded and then you can also run the predictions. So this is from the models that's already there on the platform. So when you run the prediction, so you just also select the model ID, which you can find here. This is the model ID. So you can just use it to do your inference from the API calls. So as it's running, so this is the output. So here you see all the detections. So from a developer or technical perspective, you see the label, the confidence threshold, and these are the coordinates of the bounding box. So all of the lists are up there, and then the image. So you can easily visualize the annotated image. That's from the prediction right away. So this is just a small notebook, but the SDK has more stuff that maybe you can go through, and if there is if there is any feature you want that is not available, you can also reach us, and then we will incorporate that for you. And if you want to use the platform, you can sign up and use it. So we already have, when you sign up, you get up to 30 days free to use the platform. And then we also providing credits for the first 20 that joined. So you can have access to it for about 3 months to use the platform. Okay, so I will share the form. I think the organizing team will share the form around for you to fill so that I'll forward the credits to you. So with the credits, you can redeem the credits from, I think from here. Yes, redeem credits from here. Yeah, so you just enter the credits. Yeah. All right, so this is also the pricing we have. So for the free, you have free access to it for 30 days. And then if you want to use incorporate it in your team and use for a long term. So the credits, you have access to the credits for the starter for 3 months to use as well.
Okay, thank you very much. I think Philip, the link is in the chat. So the link to the form is in the chat. So we could do the registration by adding our emails and all that. Yeah. So I think Epigos AI is doing a very good job by giving us is it $450 worth of credits at least. It's something
yes,
that
$150.
yeah for 3
$150.
months. So
Yeah.
for 3 months. So I think it's a very good gesture from them that needs to be commended. Yes, thank you very much. So I think there's one hand up that we might have to look at then. Maybe if
Okay, sure.
you can start rounding up or something. Thank you.
Yeah, sure. Yeah, please, you can go ahead with your question.
Good evening. Please, my name is Etonam. I wanted to ask, does the SDK allow you to send stuff from the Colab back to the platform, or is just platform to Colab?
No, so you can send from Colab to the platform. So this particular one, we uploaded the images from Colab to the platform. And then you can make predictions anywhere. So for this, we uploaded a subset of the images from Colab to the platform. So I named it Gain 2. That's the name of the badge upload. So you could, if you go to the platform, you see it here, Gain 2. It's uploaded, and together with all the annotations. So you see the annotations are all shown here. And then we also made prediction from Colab, yeah, which using this method.
All right, thank you very much.
All right. Okay, I think that should be it from my side. If there is any more questions, I can take them. Then, yeah.
Yeah, I just wanted to clarify the question the question from is it Ethonam, right? Yes, I think the interaction here we are using Colab, but it will be your normal application, so that we are not fixated on Colab, like always looking out for Colab. So whatever application you are developing, you can do the communication. It's a bi-directional communication, I guess. That's just some clarification I just wanted to make with respect to the question. Yes, so thank you.
Yeah, that is correct. Yeah, so basically, if you can run it in any Python environment. So installing the SDK. So whichever platform you are using, you can run. Cool. Yeah, that is it for me.
All right. Thank you so very much, Philip. And I believe that this has been a really insightful session for both you and us. And actually, that is what GAIN stands for. We give you the opportunity to enlighten us on your contributions to AI. And then the questions and comments will also provide ways to improve on what you have. And so I am sure that we have learned something new today, and we would carry the knowledge beyond what just ended. So thank you so very much, Philip, for making time with us today. We are most grateful. And I would also want to say that we have an AI Innovation Challenge coming up. So for everyone here, if you have some really good solutions to societal problems, you can register. You can find the link on our website and also on our LinkedIn, as well as our X, yes, our X platform. Yes, you can find the website, the link, right, or the flyer to the Innovation Challenge. We highly encourage you to register, submit a project, and stand the chance of winning 50,000 Ghana cedis, as well as industry recognition and the national spotlight. So we encourage everyone to, as many as can, you can even form a team, right? Put in the application and let's provide some good solutions to the problems that we face as a community. So thank you very much, Philip, and thank you so very much, participants, for making time for this session today. And we will be seeing you again next month. When the date is out, we would let you know. So we thank you so very much for your participation and your time today, Philip, and to all participants. Thank you so very much. Enjoy the rest of your evening.
Yeah, the flyer
You're
is in the
welcome.
chat. Yeah, the flyer to the challenge is in the chat, so I'm
Okay.
sure they can also check it from there. Thanks.
All
Yes,
right. So
thanks,
you
All
can
Philip.
right.
Thanks,
find
Philip,
details
for
of
All
the
right.
innovation challenge on the flyer. So we look forward to receiving your projects. Thank you.
All right. Thank you all for joining us all. And yeah, good to hoping to see you guys and what projects you can also do on the platform.
Sure, sure. Thank you, Philip.
Okay.
Bye.
Bye.